All right, guys. So let me welcome here the PCP guys, Andreas Gastmeier and Nathan Scott. So
thank you.
Please.
Hi, everybody. So we're visiting Brno for the last couple of days. Andreas, myself, and Mark Goodwin here are the PCP engineering team at Red Hat. We look after Performance Copilot in RHEL with the help of many other folk. And today's talk is about Performance Copilot initially. So I'm going to give you a good overview of what PCP is all about and what you can use it for. And Andreas is then, I'll switch over to Andreas and he'll talk about some of the new work we've been doing just recently that will be in future versions of RHEL, not yet released, that is introducing Grafana into RHEL and the work that he's been doing to make PCP work nicely with Grafana. But I'm going to give you an overview of PCP first, in case you've never come across PCP before, or if you want to learn a bit more about it. First thing I want to start with is if you take anything away from this talk using PCP, if you want to just go and try it out, the very easiest way using either Fedora or RHEL is to just install this package called PCP ZeroConf, and that will install a lot of interesting pieces which I'll show you today from PCP and enable them automatically. So this is what we encourage customers to do, and the Red Hat Customer Support Organization when they're trying to analyze performance problems on customer systems, because it gives you a very easy initial setup for PCP. PCP is quite complicated, and there are many parts to it. So it follows the Unix design philosophy of having many small tools, but that can be quite overwhelming because there's potentially hundreds of little tools in PCP that you can use for performance analysis, and people often don't know where to start when it's all new to you. So DNF install PCP ZeroConf is a good thing to remember to get you started with PCP. So it's suitable for all systems. PCP is available on all sort of modern RHELs that we ship from RHEL 6.6 onwards. For every platform, so every hardware platform that we support at Red Hat, you can use PCP on that. I'll talk about some of the features in PCP that are particularly useful for the Red Hat Customer Support Organization, in particular being able to analyze data on your laptop. That is PCP data that's come from a customer system that might be of a different architecture, so perhaps S390 data, PowerPC data, whatever, that you can still analyze using PCP tools on your laptop, which is quite unique to PCP. Many other performance tools don't let you do that sort of thing. So if you go ahead with a ZeroConf installation, it will install PCP, PCP libraries, the Python APIs for PCP, and some Python tools, and it will start PCP service on your system, whether it's a laptop or whatever. So often the first command that I'll run, I'll give you a quick demo here, on a system that I've just perhaps installed PCP on, is the PCP command itself, and it will give you an overview of what PCP services are running on that system. So this is a typical setup if you've just installed PCP ZeroConf. You can see things like the version of PCP and other information about PCP. The same command can be run on a PCP archive. I'll talk a bit about what the archives are, but you'll find that exact notion of being able to run a PCP command live on a host, so collecting real-time data and reporting it, or against recorded PCP data. Most of the tools are interchangeable, so you can run PCP live, or you can run exactly the same tool in exactly the same way, typically, on historical data that you may have got from some other system, your own system, a customer system. And this is the sort of stuff you see on a default PCP install. So it'll tell you sort of what your hardware is, what kernel you're running, in which PCP services. So this particular example has only PMCD service running in terms of daemons. And all the other data there, I'll explain to you over the course of this talk what it means. In particular, I'll go into the logging PM logger tool, the PMIE tool. I'll talk a bit about those towards the end, so I'll skip those for now. Probably the other interesting thing to touch on here is a bit of PCP architecture. So we can see there's a line that says PMDA. third from the bottom, that tells you which agents, so PMDA is a performance metric domain agent, which agents are running on this machine collecting data. So we can see we have some agents that are instrumenting PCP itself. We have per process data, XFS metrics, Linux kernel, NFS client metrics, and several other agents that are running. And that's a typical default set, but that's extensible, which I'll talk about more. You can add your own performance data using these agents.
What are the clients again?
Sorry?
So you spoke about the agents, but there have been also a notion that there are 10 clients connected. What does it mean?
Okay, so PMCD, if I just switch back, is the server. That's the main live collection data. So we'll have agents connected and we'll have clients. Clients are the tools that are asking for current values of performance data. So I'll go through and show you some examples, but as an example here, this PCP command is a client itself because it's asking PMCD, tell me about the platform that you're running on. And PMCD will say, this is the hardware, these are the agents that are running there, this is how many disks you have. So yeah, definitely important note is that there's a client-server architecture in PCP. Server is the thing that's extracting data from the kernel, from databases, whatever. Clients are the tools that are going to be analyzing that data. So they're asking for the data and either reporting it or recording it or taking action based on the data that they see. But yeah, so just remember PCP ZeroConf, it's a handy one-step setup. So I've done some basics already in terms of a quick start. So PCP ZeroConf, run PCP, you've got a basic overview of your PCP setup on your local host. So that's kind of the how and the what. I'll go through with some examples of various PCP commands. I'll talk a lot about the PCP architecture, some of which I've talked about the client-server stuff already. And then I'll switch over to Andreas and he'll show you some of the new Grafana tools. So I'll skip that stuff. But important notes here, once you've installed PCP, you can immediately start getting results. So as I showed, you run the PCP command and you have data straight away. I mentioned that PCP is a toolkit, so we have lots of APIs for extracting data or adding new data. And there's lots of tools that we've written that use those APIs, but you're actively, if you have your own performance data, you're encouraged to add agents, or if you have your own analysis needs, you can add client tools, all using these PCP APIs that we make available and use in our own tool. I'll show you now. And finally, I'll talk a bit about production performance analysis and how we use PCP in anger. How large companies, large sites are using PCP for 24/7 performance analysis, and some of the critical tools if you're doing that, which you should have running all the time. In particular, PM Logger and PM Money, so I'll come back to those. And all through this talk, I'll have small little demos which I'll show you. So let me quickly switch over to those again and run another one for you. So I'll also start with the very basic PCP commands and build my way up. We've looked at the PCP command, doesn't get much simpler than that. The next thing we want to look at is all of the available metrics, performance metrics that are available from your system. It's pretty straightforward to do that with PCP. There's a little command called PMinfo, which by default just gives you a list of all the metrics. So you can see in that example, we have a hierarchical namespace for PCP metrics. So every metric has a name. In most recent versions of PCP, the last couple of years or so, metrics also have labels. I won't talk much about that, but for today's purposes, it's important to know every metric has a name. So any piece of data, performance data that you might be interested in PCP, there will be a name associated with that.
What is the time resolution of the metrics? I mean, I see there are milliseconds, seconds, but it's important to know the resolution of our metrics. So what is the...
Okay, so I can answer that several ways. So in terms of a metric itself, the resolution or perhaps the type you might mean. You can have like a 64-bit value, a 32-bit value.
It's more about the issue about timing. I mean, you can have, let's say, measurements every half a second or every 1/10 of a second or every 5 seconds. It's important to know this because we can identify.
Yep. So the tool that does recording of data in PCP is called PM Logger, which I'll talk about a bit more at the end, but I'll answer your question now. You basically configure it. You tell it how often you want to record. So if you want to record every 20 milliseconds performance data, you tell this tool, I want to record these metrics with these names at a 20 millisecond resolution, and it will do that for you. So it's a client tool, PM Logger, next to PMCD, and starts sampling at that rate that you ask it to, and will records timestamps for every sample at a high resolution, and will do it for as long as you ask it to. But that's an interesting point about PCP is that everything is completely configurable. So you can choose to log as much or as little as you want. So you can log a specific, like an individual metric, just reads for a single disk device if that's all that's of interest to you. You can log it at a very high rate, and that will work just fine with all the PCP tools. Or you can log huge amounts of data at high resolution, low resolution. You can log some data at one resolution, other data at another resolution. So back to what is a metric. So a metric is the fundamental core concept really in PCP, other than time itself. With a metric, we have values over a time. So metrics are essentially a time series once they're instantiated. But from a philosophical point of view, back to what makes up a metric, we have the name, identification, and label, name and labels. We record in PCP for every metric, whether it's a counter metric, so a metric that's slowly increasing or rapidly increasing its value, or whether it's an instantaneous value, like a gauge you may have come across in other tools. So a gauge is like memory utilization, it goes up and down depending on what's happening on the system. And a counter is like a number of bytes across a network interface. So the kernel just keeps adding onto that value. It's exported as a counter. This information is really important for client tools that are analyzing the data, because if you don't know if something's a counter or an instantaneous value, you don't know how to record it. Because raw counter values are not particularly interesting on their own. What you want to do is look at the change in that counter over a period of time. And so you have to know, is it a counter or instantaneous? And there's several other bits of metadata we store with every single PCP metric. So this is kind of unique to PCP. Most other performance tools don't have this kind of strict metadata associated with every metric. But it's important in PCP because the client tools will consume it. So the client tools want to know what the units are for every metric, for example, so they can make sense of graphs. And you can graph different things together. If you have a value that's in kilobytes and another value that's in bytes, the tools can look at both of those metrics and say, I need to scale this one so that it makes sense to plot with the other one. The tools can do that. Yeah, so the only other interesting thing there that can be a little bit subtle, I guess, is the last thing. PCP metrics have a concept of an instance domain, which I'll talk a bit more about on the next slide. And this is basically, instead of just a metric having one value, a metric can have a set of values associated with it. So, for example, number of reads to a disk device, that metric can have a value for every disk device you might have on the system, or number of bytes across a network interface, that will have a value for every network interface. So when you see instance domains in PCP, that's what that's talking about. So let me give another quick little demo. So this is PM info again. This time we're going to look at just the file system metrics, and we'll look at one metric in particular. So we get the descriptor, the metadata I was just talking about. This is how you would see it in PCP. You can ask for a descriptor, and it will tell you that. You can ask for the current value, which is fetch, and it will go up and fetch the current value. This particular metric has an instance domain, so we have a set of values, all the mounted file systems and how much capacity they have. So you can see you can quickly have a huge amount of data. So in PCP, we have, from my earlier example, several thousand metrics straight out of the box. That's with just the default agents. and those metrics can have potentially tens, hundreds, even thousands of values associated with them. So we can very quickly get large amounts of data out of the system with PCP. Right.
Was the instance domain 60.5? Is that?
So that's an internal identifier that's used to identify that set of values, so that set of instances. So to go into it a little bit further, every metric has an internal identifier. The instance domains do too. And I won't go much more deeper, I guess. But the 60 says which agent is exporting that metric, and 5 is just, this is the fifth set of things that agent is exporting.
And was the 0xf?
That's just the hex version of the same number.
Okay, thank you.
Yeah. Go ahead.
So you have the instances numbered from 0 to 3. Now, what happens if you keep logging over time and the dev fuse gets unmounted and different thing gets mounted? So, like, will the numbers or the indices matter, or will the names matter, or how will that?
Yes, it all matters. So what will happen when you unmount a file system, say unmount dev fuse, that instance will go away when I next fetch the value because it's no longer mounted. That value 3 will not be used in the short to medium term. If I mount another file system, it'll come up as number 4. If I remount dev fuse later, it'll get the end on number 3 again and will be exported with the same name. So there's a rule that we have in the agents that if something has meaning over time, even if the instance comes and goes, we try very hard to keep the same instance domain number. So it's kind of a subtle point, I guess. And once you start writing tools, you might see a bit more of why that's important. But at a user level, it's often not that important. Sure.
About the resolutions. So when I have some value as kilobytes per second, obviously that doesn't make sense as instantaneous value. It has to be averaged over, let's say, a second period, something like this. So can I get metadata for this value of the window of second or so?
So that's an interesting case. So kilobytes per second is a value that has been rate converted already. So if I have a value that's 10, let's say it's 10 kilobytes per second throughput to a disk, that is a counter that has already been rate converted. So it is now an instantaneous value because I might, between two samples, I might have 10 megabytes per second throughput. The next sample I might have 2. Next sample I might have 20. So you can see that pattern goes up and down. However, the raw underlying counter that the kernel is exporting is a counter. So the metric is a counter, which is the number of bytes that the kernel is writing.
So the agent or stuff like this is looking at the counter and it's computing the rate out of this value.
That's right. It's actually the client tool that does it. So the client tool will typically say, give me the raw values, and it will get the number of bytes that have been written to a disk over several samples. And then when it reports it to you, it'll do the rate conversion over those samples. And say, between 2 and 3, we did 20 megabytes a second. Right, so that's metrics. So these are just the fundamental concepts of PCP that we've got to get across so that we understand what we're all talking about. The other interesting thing, I guess, is what is a source of metrics. In PCP, you'll see that term come up occasionally. A source of metrics is just where they've come from the point of view of a PCP client tool. And that means, so the possible values of source or possible types of source are a live machine that you're analyzing in real time, so it's a host. There's also a special case, which is shared libraries, but just ignore that for now. So you don't actually have a daemon. You can directly, a client can directly talk to the that extracts values. But essentially, both of those are for a host, and they're live data. The other source of metrics is a PCP archive. So we've recorded some PCP data, and that's now historical data that we have from yesterday, last week, 2 years ago. And that source is a PCP archive. So we'll see in the examples that I give now, some of the tools will be running using live, some will use archive. These things are interchangeable in PCP. I think I explained metric domains already a little bit. The domain concept is what an agent exports. So an agent exports a domain of performance data. And we have agents or domains of data that are things like the kernel. your hardware. Device driver, a database like Postgres or MySQL, whatever, each of those has its own domain, and there's a special bit of code that's written inside PCP for each of those things. So it's not a big blob that knows everything about everything. We have small bits of code that plug in and say, I know about this database, or I know about this device driver. So that's a domain in PCP terminology. So let's keep going with our tools examples. I think the next one. So here's an example of another simple command line tool that we ship with every PCP installation. PMStat, it's a bit like VMstat, except it runs both live and with archives. It can also run across multiple hosts at once. So we'll see here, I'm looking at 2 hosts at once, and it will collect data from both of those hosts and report it in much the same way as it would one host. And that's a useful thing with PCP. So PCP was designed pretty much from day one to be analysing complex systems. So we're not just looking at one system anymore, like SAR was trained to do. We're looking at multiple systems at once, potentially. And just to quickly touch on it, so PCP was originally designed for relatively small numbers of systems. In recent years, we've been ramping that up to hundreds to thousands of machines. Start analysing at once. Well, Andreas will show you a bit later. Go ahead.
What's the authentication mechanism against the remote machine?
So by default, so when I run PMStat like this, it will connect to PMCD on the local host if I don't give a host. That will be over a Unix domain socket. So there's that Unix domain authentication happens there. If you're connecting to a remote PMCD, there is authentication built into the protocol. For PCP, it uses SASL and encrypted connections if you choose to enable that. But it's SASL, so you can plug in whatever authentication you choose. Right, that's PMStat. All right, so we'll keep going up our chain of PCP tools. So PCP has some graphical user interface tools as well, like desktop applications. The most useful one is PMChart. This example is just showing PMChart with a couple of live hosts, I think, yep, Slick and Shard, and showing how you'd go about creating a chart. We ship several predefined configurations, or what we call views in PCP, and you can run each of those views potentially against a different host, which is what I've done here. So this is showing network interface activities on 2 machines side by side as the activity is happening on those machines. And it's that easy and quick. That's all you need to do. You don't have to set up much other than just the default PCP install. And it's nice and quick, yeah. So the next interesting thing to show is this same tool. It runs against historical PCP data in exactly the same way pretty much as with live data. So we can open this archive, historical data. I can open pretty much the same view and bring up the time controls and move to different places in the archive and replay the data that was recorded at that time. When you're in archive mode like this, you have a few more options in terms of moving around. Obviously, you have historical data, so you can go back in time, which you can't have when you're doing real-time analysis. This mode, you're running, looking at recorded data. Go ahead.
Are you doing something to align the clocks between machines when you are showing multiple machines at the same time?
No, not within PCP. So if you're needing that, which most people do, you'd be running like NTPD, something to synchronize your clock. We don't try to do that. We use get time of day as the system call we use, and that is assumed to be aligned.
What is the average size of, let's say, a standard performance collection for a day, or some average metrics or some default metrics per server?
So there's 2 ways to answer that. So if we just straight out record with PM Logger running, it'll and we do like a default config. It depends on the size of the machine in some ways. So for example, if I'm looking at my laptop, might have 2 or 3 or 4 or 5 CPUs versus a supercomputer with thousands of machines. huge difference for the same metrics. But just let's say a simple, like on my laptop, if I'm recording for a day, quite a decent set, a few hundred metrics at quite a high interval, so maybe every 10 seconds, it'll typically be less than 100 megabytes, so uncompressed. And the way we set up the loggers, which I'll talk a bit about later, they automatically compress during the day. So if a log reaches a certain size, it'll start compressing it straight away. So there's a lot of control given over how quickly you start to compress and all sorts of, like, all the different tunables, how many metrics, how often. Go ahead.
Hi. Can PCP measure its own overhead or
Yes.
like the metric it's being measuring?
Yes, we do. So we export, for example, in PMCD, we export a series of metrics about how it's going, like how much CPU it's using, how many messages are coming in and out, how the agents are children of PMCD, what state they're in, how many messages they've sent, things like that. Yeah, we do that. Which is really important. So in my last life, before Red Hat, I worked as a performance analyst at a company. We introduced PCP many years ago, and there were so many performance problems here. We had a production outage, and we just enabled PCP. Of course, the finger of blame was quickly pointed at PCP for installing it, and we used those metrics to prove actually PCP is running just fine. It's not using any very, very few resources at all, and the actual problem was over here. So, was that a question?
Yeah. Speaking about overhead, what overhead figures, what numbers we can expect, and does this overhead scales up with the overall system load?
Yep. So system load doesn't tend to affect PCP's throughput. So you basically configure PCP, start it logging usually, and it basically is fixed what it's going to use. So it will typically request the same metrics over and over again on whatever sample you ask, and it will record those for you, and it will use the fixed set of resources. So the very low CPU overhead typically, unless you log things like sub-second intervals, which you can with PCP. You can log things very, very fast, and then it uses as much CPU as it uses, and you can log as fast as you can, and eventually you'll make the daemons use all the CPU, because they have to use some CPU. But in a typical installation, it's very, very low. So in that example where I just gave, where I was involved in that production system analysis, we were able to prove that PCP was very low overhead on CPU and network because we looked at the traffic in PCP, and there was at certain times of the day essentially no CPU load. So in default mode of operation for PCP, you can expect to see no CPU overhead from PCP. It's very minimal. The daemons are written in C, so they're relatively lightweight. So most of them are written in C. There's some other types of code. So we have agents, APIs, and you can write Python agents, Perl agents, or whatever. But PMCD itself is just a small C program, so it doesn't use much memory by default. The agents that we install by default don't use much memory either. So it's all designed to be low overhead. So that's a big design goal with PCP, is that we want to be not part of the performance problem you're trying to solve, but part of the solution.
Excuse my ignorance here. Is Grafana a performance metrics thing, or what is the competitor of this tool?
Oh, there are many competitors.
And what is the...
So let me come back to that. So Andreas is going to give a talk wherever he's gone about Grafana right after mine. So he'll explain to you exactly what Grafana is. Grafana works.
Yeah, we try to compare.
But basically the two work together. So Grafana and PCP work hand in hand. There are hundreds, thousands of other different performance tools. That's it. Everybody loves writing their own tools. So there are many, many different tools. So there are many competitors to PCP. And that's a whole nother talk in itself. But we'll get a good overview of PCP working with Grafana from Andreas.
We will probably talk about this later, but does PCP deal with the storing of the information, or you just provide the stream of data and use some other tool to store and create the archives?
PCP will store. PCP has its own archive format, which is a time index thing. It stores data in a form that is interchangeable with the live mode. So you'll see me using, like I use this charting tool in live mode and then in archives. That's a PCP archive, so that's historical PCP data in the PCP format. There are many tools that we ship with PCP though, so if you don't want to use that and you want to use Elasticsearch or Prometheus or whatever else, we provide many tools that will help you to take data from PCP input. So all of the APIs, like I said at the start, are documented and available to be used to export PCP data or import data into PCP. Yeah, there's lots of options there. So that was PM chart. So how many examples are? I think I had some examples about these, but I've taken them out in favour of Andreas's talk right after this. I may have a DStat example because I find it an interesting tool. It uses PCP really well. Let me see. Got some demos. Yes. So this tool was added in RHEL 8. There was a lot of interesting discussion that happened around the time, but essentially DStat, which is a tool that's been in RHEL forever, was removed from RHEL in RHEL 8 because it didn't work with Python 3. And upstream weren't working on it, so we basically were tasked with making it work for Red Hat support organization. So we took it and used PCP APIs to provide the data instead of doing it itself. And this is the kind of stuff it reports. So this is live mode DStat. It has a really nice architecture, DStat, and I'd say it's even nicer now. You can write your own little output formats, things that you want to view in DStat. So in this example, we're looking at like disk and mem, so the configurations that we've used. You can write your own configurations and the tool will just use them and report them alongside everything else, which is kind of neat. You can also see it using all of the PCP services or some of the other PCP services, like it's using units. So for every metric here, we can see whether the value is in kilobytes, bytes, megabytes. Reports that nicely, so that's a nice match with PCP. And it's completely extensible, like I said before. You can add your own columns. New metrics that you add, you can, without writing any code in DStat, you can just have automatic performance monitoring tools that exist for your data without having to write client tools. So the last interesting point here, which we added in the new DStat that we wrote, is the ability to look back at historical data. Like in this case, the original DStat was just live mode only, but because the PCP APIs are interchangeable, we were able to add this functionality. It was really important for Red Hat's customer support organization because they get archives from customers. They can't just log into the customer system typically and run DStat. Now they can run these tools that they're used to over historical customer data. That's DStat. So that was DStat. There's another tool I'll just mention quickly. So DStat is a Python tool, client tool of PCP. There's another one called PMRep, which is another Python client tool. It's like a Swiss Army chainsaw kind of tool. It has lots and lots of different options for formatting data. So you basically tell it, you run it, it's a command line tool, you say, I want to look at metrics X, Y, and Z, and I want you to format them in such and such a way. I want columns that are 5 spaces wide. I want my time to be in a certain format, and all of that sort of thing. And it will just go away and do it all nicely for you. So it's another handy one. If you're using PCP and you want to analyze your metrics, you don't have to, it's another tool, you don't have to change at all. You just use it with metrics. If you've added new metrics to PCP, or any metrics you've enabled, like if you're looking at SQL Server, the data that we provide, it just works. So you just say, I want to look at the buffer cache hit ratio in SQL Server, PMRep, and it will start reporting that nicely for you, because everything is by name. So that's a quick overview of some of the PCP tools. The last thing I wanted to talk about is longer term use of PCP. So planning ahead. So if you're in a production environment, you don't want to be running tools ad hoc. Typically, you want to have metrics being recorded all the time so that you can look back if you have a problem, you can see, okay, what was it doing last week when I didn't have this problem? You can look at all different aspects of your system. And so the way you do that is with the PM logger tool, which is recording data. And the other useful tool here is PMIE. IE standing for inference engine, PM performance metrics. So it's a performance metrics rules engine. It evaluates rules about performance that you give it. And then it takes actions when they become true. Will do things that you tell it to. So show a quick couple examples about them, but this is a more strategic use of PCP. Interesting, a lot of this stuff is switched on when you do a PCP zero conf install with just defaults. So you can change those, of course, and add your own rules, but we'll supply what we think is a good starting point. So let me see if I can bring that demo up quickly. So, that's a bit more complicated. We're not just looking at the local host, remember, we might be looking at multiple machines. So this example is showing us how we'd set up loggers for multiple machines. So in PCP, there's one PM logger for each machine that you want to log data from. And this is what a PCP configuration file looks like. This one was auto-generated. And this, I think, is kind of getting back to one or two of the questions. What that section of text is saying, that's part of a PM logger configuration. It's saying on the default time interval, whatever that is, once every 10 seconds, once every minute, log these performance metrics. So that, and those are the names of a bunch of performance metrics. So every 10 seconds, if that's the default, it'll log those metrics into the archive you ask.
The PM logger runs on the machine which is being traced or the machine which collects this distance?
That's your choice. So it can run remotely or it can run on the machine.
Yeah.
Just choose.
What about containers? I mean, how you can see values and metrics inside containers that are running on your server?
Yes, so that is possible in PCP2. So, but it's a complicated explanation. It is possible. A lot of the command line tools, so some of them will have a minus container option, and you can say, I want the values from this container, and it will do some Linux kernel magic to switch into that container. The PCP daemon will run as if it's in that container for a while it's sampling, and then it will extract the data and send it back to you. Okay. But there's plenty of different deployment scenarios people use with containers. So you could also run PMCD inside the container, depending on a whole bunch of factors. But yeah, we can go either way. I think the last little quick demo, and then I'm done, is showing how to set up PMIE, which I talked about a little bit. This is the inference engine or rules evaluation engine. Looks very much like setting up PM logger. You can set it up for multiple hosts at once. This example is showing you one particular rule. So we have a whole set of rules. Let's look at one in particular, say this entropy rule, which, and so this is the PMIE language, and it basically says if there's some host where the entropy pool, like the random entropy pool, is looking like it's drained, that can cause performance problems because when you ask for a random number, if you don't have entropy, you may have to wait. This is trying to detect that situation automatically. So it'll be running on the system and say, oh, you frequently don't have entropy, and it will write a system log entry. So any performance metric that we have, we can write rules about. So you can see how the power of having metric names is really useful. You can write generic tools as well as all the other metadata. You can write generic tools that can do things like this, have all of that metadata.
So the reason that we have this entropy value is to have a good quality on randomness for the authentications.
Yes.
For security.
Yeah, so that's really nothing to do with PCP. This is a kernel concept, this concept of entropy, such that when you make the random system call, it's pulling entropy data out of /proc/entropy or something, and is using that as part of the random number calculation, and it's going to give you back a random number.
So here you have to calculate the randomness.
No, so the kernel also tells you the size of the entropy pool that it's using, how much is being used, So we're basically just looking at values the kernel is giving us, and we're taking action if those values look like they're in a bad place. So if it's looking like we don't have entropy often, this rule will start to fire, and it will write to the system log and say, this machine doesn't have entropy, and we're trying to use entropy, but we're trying to generate random numbers, and this could be causing stalls. But this is just an example, right? So you could write rules about your Oracle database, your some other service, and anything else. I'm going to jump out of here. So I think that's pretty much all I have. So another quick overview. We talked about PMCD. That's the main daemon in PCP for extracting live data. Talked a bit about PMIE. That's the rules engine we just looked at. Talked about PMLogger. That's the tool for recording performance metrics in PCP. ZeroConf will switch all of those things on for you. There's some articles if you're interested in reading more about PCP. And I can probably make these slides available. That is it from me. So I'll hand you over to Andreas, and he can give us an overview of the work he's been doing with Grafana.
So I'll present you our latest work with Grafana. Our latest integration. My name is Andreas Gerstner. I'm working with Mark and Nathan on PCP. And my work in the last few months was the integration of Grafana with PCP. So probably most of you already know Grafana. It's a dashboard tool, a browser-based dashboard tool. It consists of dashboards, which consists of panel. Each panel is, for example, a graph, a heat map, or line chart, or some other value. And these panels get the data from data sources. And to integrate Grafana with PCP, we created 3 data sources. So the first one is for Redis. So if you want, PCP usually logs data locally in archives. But if you want if you have PCP installed on multiple hosts and you want to aggregate the data and visualize it in one graph, you probably want to use the Redis backend so that the performance metrics are stored in a Redis database. And with Grafana PCP, you can query the Redis database. The vector data source, it's at first, Netflix created a standalone web application called Vector, and it used to connect to PM WebD and collect live metrics from their hosts. And recently, Netflix decided they will stop, continue working on Vector and moving it to a Grafana plugin. So they did an initial prototype for a Grafana plugin, which has basically the same functionality as their old standalone vector application. I based my work upon it and improved it, added a lot of more features and a lot more tests, and it works. So basically, if you want to know which kind of these data sources you should use, if you want historical data, you use the Redis one. And if you want instant metrics and you don't care about the history, you use the vector one. The third data source is bpftrace. It allows you to create bpftrace scripts in Grafana, and they are automatically started on the host and export the metrics in real time, and you see them in Grafana. So I'll give you a live demo of Grafana. So this is the Grafana dashboard. Here is the Performance Copilot app. I'll enable it. Then you have to set up the data sources. So I'll set up here is the list of data sources Grafana is supporting. Here we set up vector, you enter the address. Then you can select if you want that.
Can you increase the resolution because it's quite small and we don't see? Yeah, you know it's too much now, but it's.
Yeah, I'm not sure how nice the dashboards will look, but
No.
we'll see.
That's fine.
You can minimize later. Don't worry.
And yeah, here you can select if the how the data should be accessed. If you select browser, then the browser is querying the browser is directly sending an AJAX request to the configured address here. And if you select server, it's doing an AJAX request to the Grafana daemon. Grafana runs as a daemon, and Grafana daemon is proxying it to the actual address. So, for example, if you run the performance the PCP agents in some corporate network, and you have some reverse proxy setup which serves Grafana, and you want to access it from outside, you will use the server one. So you can access Grafana to a reverse proxy, and then it forwards it to the internal network and to the PCP daemons. I'll use browser here because I have everything locally installed anyway. Then I'll quickly set up the others. It's the Redis one. Same address, everything runs on PM proxy now. That's the daemon who has a REST API, who serves the PCP metrics over a REST API to Grafana or any other tool. And lately the PCP. So now we have the data sources set up, and we'll start with a sample dashboard. So first you can either start with the query or the visualization. You can start with the query. And here we see the empty query. Here you can select which data source to use. I set up default as vector. In this case, it doesn't matter. And here you enter the query. So as Nathan explained, the PCP metrics are in a hierarchical namespace. So for example, if you want to see the throughput of the disk, the metric is called disk.dev.write. We want it in bytes. We see here some autocompletion. It's a counter. The unit is in kilobytes, and it says the amount of bytes written. And in Grafana here, you select which data you want. Do it in the last 5 minutes because we don't have any other data anyway because I'm using the vector, so it's instant metrics. And here you can set up if you wanted an automatic refresh, for example, every 5 seconds. Now we have every 5 seconds, it's refreshing, it's getting instant metrics from PM proxy. PM proxy serves the REST API, and it's getting metrics from a PM data agent. And here you can see Grafana doesn't know about the unit, so we should select the unit we are using. In the autocompletion, it mentioned this unit is using kilobytes. So we're setting kilobytes per second. And this metric is a counter metric, so the kernel exports just a number which is always increasing, and Grafana data source does the read conversation automatically. So now we have the graph of the metrics. We can try it with a short DE test. Every 5 seconds we have the refresh, and we see there's some increase on my NVMe storage. And we can also add multiple metrics in the same graph. You can duplicate it. For example, if you want to see the amount of read throughput, metric is called read bytes. And now we have both metrics here. But we have a problem now. You can't differentiate between these two because one of them is for reads and one for writes. So you can supply a custom legend. You, for example, here for the writes, you want write with the instance name. So we have the write matrix starting with write and then the instance name. Here you can see the possible variables. It varies. The metric is just the metric name. Metric 0 is the last part, an instance, is the one I used. So for example, if you have multiple disks, the name of the disk. And an interesting feature of Grafana is, because right now it doesn't look so nice. For example, I have to do this here also. And if I want that some graph is in the negative, so that I have both metrics in the same graph, but I can properly see it. I can have a series override. I can just write a regex. For example, I want to transform the right in I want to transform the value. So now I have the positive numbers are the reads and the negative numbers are the writes. Start it again. This is an action in the graph. 5 seconds, you have to refresh and if you read it. It's probably the cache, the page cache. So.
I see these values of 1.2 gigabytes of data. What is DD or something? What exactly you?
DD it's just copying in this example, in the previous one, copying zeros into a file called test. And it's using 10 kilobytes of blocks and 50 times. And
so that's why it's these big numbers, right? Because if you put some bigger thing, that numbers would go. It's nice numbers, but now I get why.
Yeah, it's basically not writing actually to the disk. It's more in the page cache, and that's why it's so fast.
So it would be probably better if you could like read def SDA and copy that to dev now or something. That would be the reads.
Careful.
No. Yeah, sorry.
How much memory do you have?
Yeah, it's very
I have to check what's going on here.
But this is on cache, it's not actually transferred somewhere. That's why you have that number. So if you have, let's say, 50 megabytes or 100 megabytes, that doesn't count.
But anyway, it's Edinburgh.
And for the we also have sample dashboards for all the data sources. For example, for vector, we have a host overview dashboard, which gives you a lot of sample metrics. Like CPU, load, that stuff. But because time is running out, I'm quickly go over to I only cover Redis very shortly. It's basically, I have to cover Redis because it's basically the same as vector, just it does it whereas the Redis data source instead of live metrics. So, because probably you are more interested in PPF trace, so I'll show the PPF trace.
So Vector is the Grafana plugin to present the graphs you want, or what is Vector?
Vector, it used to be a standalone web application from Netflix and varying the metric, instant metrics from the REST API from PCP. And now they decided to drop it because it re-implemented a lot of stuff which Grafana already has, like all the charting, all the refreshing, and a lot of stuff which Grafana already has. So that's why they did a data source plugin instead. They made some prototype, and I based my work upon it and extended this part.
So these days, Vector is the data plugin
data source.
for Grafana, which can read the sources from PCP.
Yes,
right?
exactly.
Okay, thank you.
And so I'll show you a BPF trace metric. Let's start with query. We have the BPF trace. And we, for example, are interested in the kernel function /write. That's the virtual file system write. And we're interested in the return value of this function because it gives you the amount of bytes which were written. So you have an auto-completion about all the available probes in BPF trace. Here we want a kernel return probe, /ret probe, and it's the virtual file system write. Then you so every time when the kernel is executing this function, BPF trace is called, and we want to save the bytes in a histogram. So we declare a variable bytes, all variables start with an add, and we want the history with also auto completion here of the return value. The return value is a built-in variable in BPF trace. And for this, we have to set up a few things. For example, we want to display it as a heat map. We set up heat map. And Grafana wants it in a specific format. We have to tell Grafana that it's a heat map. So we also have to change the visualization. That's the panel heat map. And BPF aggregates the data in packets in the kernel, so it's much faster. Otherwise, you would have to transport all the single matrix to the user space and it's slow. So we have time series packet.
A bit the term of heat map. I mean, I understand the term of heat map if you have, let's say, 50 disks and each one of them has its own way of load, so you can have a heat map there.
Yeah.
But heat map here is what is the object of the heat map? What are the objects?
I'll sure. We have the unit in bytes, and because we don't have any historical data anyway. We want to increase the refresh. This is the heat map, and it shows you, it aggregates the return value of this function in buckets. So this bucket shows you the count is the number, how many how often this bucket got hit basically, how often the value was inside this bucket.
The size of, let's say, of your transactions per...
Yeah. So if I do the DD again, with test, we should see an increase in the bucket of 10 kilobytes. Here we see it's hitting this bucket a lot.
Your block size, let's say. Right? That's your block size.
Yeah. And the others?
Yeah.
Yeah, stable. For visualization, you can make it a bit nicer. You remove the...
I don't know if your BPF trace is basically a tool which allows you to hook to through kprobes to any in-kernel function. So Andreas hooked to a function called VFS writes, and not to the call of a function, but to a return of a function. VFS write, a function which is a call anytime you do a write. Because he hooked at the return of the function, he can read the return value of the function, which is how many bytes have been actually written or read, or was it VFS write, right? So he is like receiving, I don't know, like 1,000 returns of that function per second, with the amount of how many data have been written in this every point. And now he's visualizing these thousands of events in a heat map sorted by the size, how many writes have been returned from the function, and the color tells you how many events were in
the
this
events were
size,
at that
yeah.
rate. Yes.
Yeah. So you could say that the average size of a write on this machine was around 33 kilobytes or 16 kilobytes, right? 16 kilobytes.
Yes. So
because he's writing
some returns
16
of 50
kilobytes.
Yeah, right now I'm writing.
So basically,
10
it's
kilobytes
histogram
process,
rolling in
so
time,
that's why
right?
Your DD is writing what? Your DD is writing how many?
the block size is 10 kilobytes. So that's
Okay.
why this
It
function,
rounds out to the 16. Well, it's normal.
this function returns now a lot.
If you change your block size, it will be change the distribution. Let's
Yeah.
say you put 1 megabyte.
We'll change it to
I said 16 because the scale is multiplied by 2, so I can tell you it's between 8 and 16.
Yeah, it's normal. It has to be there. It goes there.
if it's smaller. It's
Now it's smaller.
7 bytes. See it here.
It might be all cached at flash. Oh, there it is. Okay.
That's right. It'll be doing less
between
of the
7
large
and
one
15.
because the large one takes longer, right? So the color won't be
Yeah,
quite as
that's
pronounced.
why the color wasn't properly visible.
Yeah,
It's
I
really
would go
interesting.
for
I just noticed
120.
Looking at
to
this,
see the-
we have -1 as the base. I'm
That's
wondering
for
what
errors.
that, but it'll tell you if you've got a lot of errors on VFS, right? Like, does that happen sometimes? If you've got bad code or whatever, and it'll show you that. It's actually really.
But now we see that the hitmap returns 7 bytes, or in the terms of 7 bytes, and I don't get it. You reduced the size because I cannot see so far away exactly the DD.
The DD, it's
Oh, start. Oh yes. Okay.
The block size is now 7?
Yes. Can you increase it, let's say, to
terminal. Yeah.
120 kilobytes?
Then you will see it here. It's very light because it takes slower, so there's not much hits in this bucket.
Yeah, but it's visible. Yeah.
It's a bit visible, yeah. And we have a lot of predefined PPF trace tools in the system analysis dashboard. They're all starting a PPF trace script in the background, and if you close the browser or if you don't request the value anymore, they get stopped automatically in the background. So here we have it's basically all tools are from the PPF trace repository. Most of them are written from Brno, so I should give credits. The credits are due. And for example, if you look at this, it's the PPF trace code and directly in Grafana. And it also supports tables, which are also interesting. For example, the connect call. If I do a curl request for the Cloudflare DNS, I use it because the IP is easy to remember. And it's not only DNS, it also has an HTTP endpoint, so we get actually a response. So we see destination address is 1.1.1.1 and port 80. And the script is here. Yeah. Here we were talking with Stanislav that if we include the BTF format, if BPF trace is including it, we don't need the includes anymore. And maybe we also can do a syntax highlighting of the, not syntax highlighting, auto-completion of structs. But yeah, that's maybe it's well 8.2, oh, 8.3. Not 8.2. And also an interesting feature, because with PPF trace, you can also sample stack traces. So I integrated D3 flame graph into Grafana, and I set up it showing us the aggregated results of the last 5 seconds, refreshing every second, and here you see the stack traces. So this is the function which got sampled. At the moment in the settings I set it, it's sampling 99 times per second. It's writing it in an eBPF map with the stack frame as an ID, and it's counting it. So if we freeze it.
So this is going to land in 8.2, right?
Yeah.
Can I use BPFs for probing user space programs? Just
Yes.
like system tab?
You also have the user stacks.
So this should give you pretty much the same power as system tab, except that it will be a little restricted because system tab is using kernel modules which are completely unrestricted. You can break your system anyway, while the BPF is giving you a virtual machine which has a lot of restrictions so you don't break the system. Most importantly, there have been limitations on like the size of the program, and also you can't loop forever. So like you can't write completely arbitrary programs. For example, you can't. That's why the BPF trace doesn't give you like a C language to do unlimited loops. There's no way you could express loops in the program itself.
And with the flame graphs, you can also zoom into something. You can see how many samples are traced in this one. You can search for stuff. Right, it gets highlighted in violet. And if you reset it,
Is this the standard flame graph code, or are you generating this manually?
It's Martin Spear, he's an engineer from Netflix. He wrote T3 flame graph for Vector originally. He exported it in a separate library, and I'm using this one.
The original flame graph code was written in parallel, licensed under CDDL by Oracle, but that means that you can't really pull it in any GPL code because GPL doesn't allow you to pull in CDDL code. That's why, and it's also because it's just Perl code which creates SVG graphics. It's kind of, once you create it, you're done. That's why they rewrote it fully in JavaScript in the D3, which allows them to create it dynamically on the fly and under GPL, I assume. That's why.
It's the Apache license.
It's Apache license. Oh, interesting. Okay. And so that's why they're using the new version of it.
That's also version of Rust.
In the beginning, you said that if I want to use real-time data, I use vector, and if I want to use stored data, I use Redis. So let's say I want to look at the real-time data like here in vector, but I want to be able to always recall what I've seen in the past. So is it like possible to use both?
You can mix and match data sources in a dashboard, so you can use both. And because the BPF is an PMD, it's an agent integrating PCP, you can also record the data and store it in a Redis database.
So if I saw some interesting flame graph 5 minutes ago, can I now go back and store it into a file?
You can theoretically store it in Redis, but it would be a lot of data because the stack traces get huge. So I think I wouldn't recommend it storing in a Redis.
So if, let's say that now it was interesting, what's the right way to capture it? I suppose you could increase the period to like 10 seconds. So you have 10 seconds to press print screen.
Basically right now it's stored locally in the browser. So if you want to go back and if you have the samples, you can select the range, for example here. It's annoying because I set the refresh for 1 second, but I can disable it. Then I can zoom in properly. And now I have the flame graphs of this period. But it's not persisted anywhere, it's only the browser and the memory right now.
And the only way to store it now is print screen.
What?
And the way to store it now is print screen.
Sorry, that's what?
So like, let's say that the data we are looking at right now, we would need some interface to just dump it to the file in some format which could be reconstructed later.
Yeah, I could do that. I could do a download JSON button.
Yeah, so that would be probably useful in the future.
Yeah, I think around the flame graph integration there would be a lot of. I'm happy to, if you give me any input how to improve the user experience for this one, because just engineering, but I'm not a performance engineer. That was how I think it's useful, but I'm happy to, if you provide me any input, how to make it better usable.
Do you have a rough estimate how much data are now stored in the memory of your browser? Like, I mean, how long it will take until Firefox just swaps out and crashes?
I don't know, we can check.
I'm still hoping it reaches few megabytes, probably still better than email. It was pretty good.
So everything we see here, we can still store in VM archives, right? But there's this disconnection between what's in VM archives and the tools I can use and Grafana, so I can't really load historical data from VM logger into Grafana right now, right? That's the
Only
only
if you
limitation.
use the reader static source. The only one that we can do historical history data. So this BPF trace and the vector stuff is all live on this.
And if I have, like, let's say 1 year old archive somewhere and I just want to correlate the data, is there any way to import the historical data from an archive into Redis so I can actually use it?
Yeah.
Is that okay? That's possible. Okay, cool.
Yep, that was it from.
You can export it by just using Selenium. Like if you want a quick hack and you want all this data, you can open the same web URL with Selenium and just use some Selenium script to extract all this ephemeral data from the browser.
I should use Selenium?
No. So the person who asked, like, what do you do if you want to save this data from the browser because it's only stored in the.
I could do some integration to export it as JSON and import it again.
Maybe.
You could use checkpoint restore in user space, which allows you to checkpoint all process and then restore. Anyway, if you could give us a button, that would be better.
The flame graph tooling that I've seen was using SVG to draw the flame graph, so this is also SVG.
This is generating the SVG on the fly with JavaScript.
And is it possible to right click on the SVG and do save?
Yeah, right now no, but I can do a button. It's easy to do.
Because I saw some fancy SVGs that even had the search functionality for flame graphs.
Yeah, I know in SVG you can also include JavaScript and you can have form fields and everything. Yep, that was from the web tracing Grafana.
Nice. So that's it. The only thing I'll say to finish up is we're here for the rest of this afternoon and we head home tonight. But if anybody wants to come and talk to us about anything, go for it. Be around.
Thanks.